Here in this question, which element has highest first ionization enthalpy? Anyone can do this question. So that is nitrogen. You can I mean మీరు కళ్ళు మూసుకుంటూ కూడా చెప్పేయచ్చు వాట్ ఈస్ ద ఆన్సర్ ఫర్ దిస్ క్వశ్చన్ అనేది. ఓకేనా? దిస్ ఈజ్ ఆన్సర్, ఐ మీన్ నైట్రోజన్ is the answer for this question. Because why nitrogen is answer for this question? Because it is having half filled configuration. You already know NS2 NP3 configuration for nitrogen. This is NS2 NP3 half filled degenerate orbital or fully filled degenerate orbital gives most stable to the if the atom has a half filled or fully filled configuration, that one becomes most stable, so that it needs a more ionization enthalpy. Dear students, in this question you need to choose what is the polar molecule. Polarity decided by dipole moment, you already know, that is here same. Your answer is this one. Why this one? Because this carbon attaches to the 4 chlorine atoms. That means all are having same energy. So that here dipole moment would be 0. That means no polarity. And here also this is also symmetrical molecule. And here also this is also symmetrical molecule. Unsymmetrical molecule is there, then that one going to show polarity. So that your answer is this one. See, here it is hydrogen, this is chlorine, and this is chlorine, and this is also chlorine. All 3 chlorine atoms are at one side and 1 hydrogen is at one side. So that dipole moment would be more from 3 chlorine atoms side and less for 1 hydrogen atom. So that this one is the more polar molecule. Understood? Dear students, here in this question you need to match column 1 and column 2, or list 1 and list 2. So here the first one is vanadium plus 1, and the next one is Mn plus, and the next one is Ni plus 2, next one is Cr plus 2. So here to identify this one you need to write first of all their atomic numbers. Vanadium is 23, chromium is 24, manganese is 25, and nickel is 28. So here vanadium 4s2 3d3, 4s2 3d3 is the vanadium's electronic configuration. So here one electron would be out, so that it would become 4s1 3d3, 4s1 3d3. Where it is 4s1 3d3, this one. So A becomes 3. Okay, next one, manganese. You can check, manganese is 4s2 3d5. Here also 3d5, one electron went out, and then after 4s1 3d5. Here it is the 4s1 3d5. See, manganese becomes 2. Next one, nickel is 28, 4s2 3d8. Here it is Ni plus 2. Ni plus 2 means these 2 electrons went out, then you will get only 3d8. This one becomes this. And the next one is, here say chromium plus 2. Chromium plus 2 means 4s1 3d5 here, but here there is no option for 3d5. That means here 1 electron would be went out. That means not 1 electron, 2 electrons. That means chromium becomes a Cr plus 2. So here it is 2 electrons. That means 3d4. Is there any option? Yes, here it is the 3d4. This is the answer, and you need to do like this. Dear students, in this question, from 6.55 grams of aniline, the maximum amount of acetanilide that can be prepared will be dash into 10 power minus 1 grams. So you can write chemical equation for this one. You can take first of all aniline. This is aniline. This one becomes acetanilide, NH NHCO CH3. This is the acetanilide. CH3CO twice in presence of acetic anhydride, this one, followed by heating. So here this is 93 grams and this one is 135 grams. So that he is asking about 93 grams will gives you 135 grams of acetanilide. So then this one gives you how much he is asking. So you can write 6.55. 135 into 6.55 upon 93. So you will get approximately 9.5 grams. Then he is asking in this form, okay, integer type. So that you can multiply and divide with 10, then it would become 95 into 10 power minus 1 grams. This is your answer. Dear students, here in this question you need to calculate about delta G naught for the reaction. You have the data. See here, 3/2 O2 gas converts to the O3 at the temperature is 298 Kelvin. So here you have Kp value and T value, and then R value also you have. So then you need to take one formula, that is delta G naught of the reaction equal to minus 2.303 RT log Kp. Okay. So you can write delta G naught of the reaction equal to minus 2.303 RT log Kp. So then you can substitute all reactions you have. Only one thing is here, you need to multiply this value with 10 power minus 3. That means kilojoules you need to convert. Okay. So that here I am writing 2.303 into, what is the temperature given here? 298 temperature, 298 Kelvin temperature, into what is the R value? 8.314 into 10 power minus 3. I already told you, joule Kelvin converted to the kilojoule. Okay. So then what is the Kp value into log 2.47 into 10 power minus 29. If you simplify this question, then you will get the answer is here 165 kilojoule. Here you will get the answer 165 kilojoule, because we already convert this joule Kelvin into kilojoule by multiplying with 10 power minus 3. You can simplify this, apply this log to these two values. That means log 2.47 plus 10 power, log 10 power minus 29, then 29 will comes front, you already know. So then you can simplify later. Okay, we will go to next question. Dear students, here in this question you need to identify what is X. Benzene reacting with carbon monoxide in presence of hydrochloric acid and anhydrous AlCl3 or CuCl. Yes, here this reaction you can able to observe in your NCERT direct bit. Okay, so this is also known as Gattam and Koch reaction. The major product is here benzaldehyde you will get. Simple question. The major product is here benzaldehyde, CHO. See, this is what? Benzaldehyde is the major product from benzene. Dear students, here in this question, see, aniline converted to X. What is the X? You need to identify here. Here you have 4 reagents. Those, by using those reagents, here see, aniline reacting with NaNO2 in presence of HCl. Step by step I am writing here. So aniline converted to the benzene diazonium chloride N2 plus Cl minus, this is, and then this benzene diazonium chloride converted to, this is CuCN in presence of KCN, benzene nitrile or cyanobenzene, C triple bond N, this is the cyanobenzene. So then this cyanobenzene converted to the benzoic acid in presence, hydrolysis. See, this is the benzoic acid. This benzoic acid converted to the benzyl alcohol CH2OH in presence of lithium aluminium hydride LiAl H4 followed by hydrolysis. See this one. So that here your answer is that the product X is here benzyl alcohol. Dear students, in this question you need to identify number of unpaired electrons present in hexa aqua cobalt. This is plus. Okay, so you need to calculate its oxidation state first. Based on VBT you need to identify number of unpaired electrons, because here water is the weak ligand. Okay, and here its oxidation state also 0, so cobalt would be +1 oxidation state. So here what is the atomic number for cobalt? That is 27. So you need to take electronic configuration for CO plus, that is 4s2 3d 7 means here 4s1 3d 7. So here, yeah, this is +2 configuration, so then these two will come out, and here also +2. So then 1 2 3 4 5 1 2 3 4 5 6. So number of unpaired electrons for this complex is 4 unpaired electrons. So your answer is here 4. Here in this question you need to write IUPAC name for this complex. Here say this is PME3 taken twice, means here it is twice, means you should use bis. Okay, so here 2 bromine atoms are there. First you can write anion's name. Okay, dibromo bis, here you can open bracket, dibromo bis trimethyl phosphine platinum 2. See this dibromo bis, here 2 is there, so that bis trimethyl phosphine platinum 2, because here its oxidation state is 2. Here in this question, which among the following halide will not show SN1 reaction? That means A is, this is allyl chloride, and this is vinyl chloride, and this is secondary alkyl halide, and this one is benzyl chloride. So here your answer is this one. The reason is here, see, if you consider this option, this one show both SN1 and also SN2. 2 reactions can able to identified by this secondary alkyl halide. Here this one show SN1 reaction, and here allyl halide also show SN1 reaction. So this one will not able to show, because here, listen, here in these 2 options you can able to observe resonance. Because of resonance, here the carbocation would be stabilized, then the stability of carbocation you can able to observe, so that here SN1 would be possible. Here both will observe, but here there is no chance to stabilize carbocation. That is the reason this is not going to involve in SN1 reaction. Dear students, here in this question, ozonolysis, here it is the alkene. So what is the product? You need to identify. The first one here you are going to observe formation of triozonide. Formation of triozonide. So then after triozonide formation, here you will get, here the bond is going to be broken up by like this, okay, so that you will get aldehyde. This is the aldehyde. Aldehyde is 2 moles of aldehyde you are going to get. So that here he is asking about per 1 mole of the molecule, how many number of oxygens are there, you need to identify. So here per 1 mole only one oxygen is there, so that your answer is 1 oxygen atom. 1 oxygen atom per 1 mole of the compound or 1 mole of the molecule. Here in this question you need to identify what are Lewis acids. Lewis acids, which one has a vacant orbital, that one going to acting as a Lewis acid. So here BCl3 and AlCl3 comes under as Lewis acids. Here in this question, for the reaction SO2 gas reacts with half mole of oxygen, they will form SO3 gas. So then if Kp equal to Kc into RT power X, where the symbols have usual meaning, then the value of X is what he is asking. That means Kp equal to Kc into RT power delta N. Here X means delta N. Here delta N equal to number of moles of products minus number of moles of reactants. So that here you can write from this reaction, that is number of moles of products means here 1 mole of SO3 formed, that means 1 minus reactant. See here it is how many, 1 by 2, and here it is also 1, that means how much it is that? So 1 plus 1 by 2, that means it would become 3 by 2. So you will get 2 minus 3 by 2, that means minus 1 by 2 is your answer.